All right, Joachim.
Hello, everyone. Welcome to the Hamoye Data Science Internship Winter 2023 cohort, Grandfinale presentation, powered by Hamoye. I'm Hakim Naimeka, your host from Enugu, Nigeria. At Hamoye, our mission is to nurture problem solvers through internship-style data-focused training. The Spring 2023 interns have excelled in machine learning with diverse data sets on topics like security, gender, and health. These interns collaborated on captivating capstone projects, exploring data sets, crafting insights, building and deploying models, and are now eager to share their findings. A special welcome to data science community members, Hamoye fellows, alumni, and our exceptional interns. Your dedication and achievements shine. Congratulations. I would also like to welcome our judges. The first judge, Charles Aditloye, is the CEO and co-founder of one of the most successful providers of consulting services and builders of large-scale distributed reactive backend systems, Maven Code. Charles has over a decade worth of experience in machine learning operations. It's good to have you join us here, Charles. Okay. Also, we have Wale Akinfadeni, who is a data scientist at Amazon, an expert in machine learning, deep learning, statistical experimentation, and general information theory. He consults for startups in the data science and artificial space. Thank you for joining us, Wale.
Yeah, thank you for having me. Excited to be here.
It's nice. Okay, on to the next, we have here with us Peter Iroja. He is the CIO of Pyro Labs, a company which helps clients to migrate to fully native business analytics solutions. He loves automation, volunteering, and learning about new technologies such as AI. Yeah, it's nice to see you here too, Peter. Okay, I would like to introduce my colleague to Ade, who will carry on with the presentations from here on. Good afternoon, Ade.
Hi, good afternoon. So, hi everyone. Just before we go into the presentation proper, please take note of each of the following. Each team will have only 7 minutes for their presentation, and you'll be given a warning to round up at 6 minutes 30 seconds mark, and you'll be stopped once the 7 minutes is up. Another thing to note, if a team is not available for its presentation at its allocated time, the team will have to forfeit their presentation. At the end of every presentation, we'll hand over to our judges for their questions and comments. Feel free to use the comment section for your comments and contributions. And finally, dear presenters, try your best to be concise and straight to the point. Remember, you have just 7 more minutes. So without any more delay, we are excited to pass the mic to our first presenters for today, Nathan Chizoba and Miracle Uche of the Catboost team. You now have the floor.
Oh, can the screen be shared? Can you hear me right now?
Yeah, I'm trying to share the screen.
Yeah.
You can try sharing your screen now. I think you have access to do so.
Okay. So good afternoon, everyone. My name is Nathan Chizola. I'll be the first presenter for Team Catboost on the topic. Catboost on the topic remittance patterns and then economic development. So next, you can see my team members. You can see the presenters. You can as well see the other active members, the project lead, the assistant project lead, and then the query analyst. Next slide, please. So we have a problem statement here. Our aim is to develop, or the problem we want to solve is to develop and deploy a model that will predict the GDP and unemployment rate of a country based on the remittance flow patterns. And if we succeed in doing that, then we're providing a platform that stakeholders will be using for forecasting, which will help them in decision making. So there are previous jobs that have been done on this particular project. Randomly, we chose at least 3, but we noticed that none of the previous research has ever done anything on deployment of the model. The best we have seen, which was what Team Bias of the last cohort did, was to develop a model, but it was never deployed. So our approach to make sure that we achieve our aim was to first of all prepare the data, explore the data, perform some feature engineering, and then develop a model, and finally deploy a model. We made use of some data sets, at least 6 data sets. We got all of them from World Bank website. We have a remittance received data set, we have remittance paid data set, population, GDP, unemployment, and then net migration data set. So we cleaned and transformed these data sets to make it useful for analysis. First of all null values between 1960 and 1969 were dropped. Then we have to replace, we have to replace all other null values that remain, start from 1970 to 2022 with zeros. After which all the wrong country names were dropped as well. Finally, we had 6 data sets that we melted and merged together for analysis. We went further to do some exploration. We noticed from our exploration that the United States was actually the country that sent the highest remittance, whereas India was the country that received the highest remittance. We further explored the data by region. Exploring the data by region, we discovered that North America, we discovered that the Europe area, the Europe region, was the area that received the highest remittance, whereas North America was the area that received the least remittance. We also looked further at the population versus net migration relationship. We noticed that countries with lower population actually have less immigrants than countries with higher population. We further explored the population versus remittance paid and population versus remittance received. We noticed that there is a pattern that shows that countries with low population tends to pay more remittance, while countries with higher population tends to receive more remittance. We then explored the net migration versus a remittance received, and then net migration versus a GDP received to see the pattern that exists. It's good to note that when net migration is positive, it means more persons are coming into a country. And when net migration is negative, it means more persons are leaving the country. So from the graph, we can see that when more persons leave the country, remittance received is increased, and when more persons come into a country, the GDP of the country increases. We further explored remittance received and then unemployment rates, and then remittance received and GDP. We noticed that when remittance received reduces or decreases, unemployment rate tends to increase. And then we notice a kind of linear relationship between remittance received and GDP. Increase in receiving normally seems to lead to increase in GDP of a country. We further explored remittance speed and then unemployment rate. It seems from the graph that when remittance are being paid, when remittance speed is reducing, unemployment rate seems to increase. We also did some hypothesis testing during the job.
Just to let you know that you have 30 seconds now.
We have this result. So I want to hand over to my colleague to tell us a little more about the hypothesis, the modeling that we did.
Continue from where my colleague stopped. For the hypothesis testing, we had to make some intelligent guesses to likely explain what relationship exists in our data set. So from our hypothesis testing, we had one of our hypotheses rejected and 7 of them accepted. And the one that was rejected basically was number 4, where we had change in migration will mean increase in remittance received. So that hypothesis was rejected, but every other thing was accepted. So we went further to engineer new features to help us actually derive more insights on relationship that are inherent between remittance patterns and economic development. And these are were the features that we developed. So after that, this actually gives us an overview of the model pipeline that we actually worked on. So first, we cleaned our data, like we prepared the data by removing the unnecessary columns. We selected the most important features based on the correlation heat map analysis that we actually conducted. And then, we further while working with categorical and numerical columns, we actually use the mean mass scala to work on the numerical columns and label encoding for the categorical columns. And then we trained and split our data sets in the ratio of 70 to 30%. And then we developed about 4 different models: random forest, XGBoost, and support vector regressor.
Time up. You have spent 7 minutes already. So,
sorry, do you mind giving them like 30 to 45 seconds more, please?
All right, no problem.
Thank you so much. Thank you so much. So for the model evaluation part, after we developed our model and we evaluated them using the MSC metric, MAE metric, MAP metric, and RMSE metric, we found out that the random forest model had better performance than every other model that was actually developed. And that's because the random forest model had the lowest score across the MSC, the MAE, and the RMSE and MAP values. But also the random forest had higher.
Sorry, can you go to your final deck?
Yes. So after that, this is a table showing the results of the model performance, and we deployed the model. And here's the model on Streamlit. And
the final
in summary,
one.
Sorry.
Yeah, go on, continue the final.
Okay. In summary, basically what this project actually revealed is that there are inherent patterns between remittance, inflow and outflow from a country and economic development. Although this particular research is not a confirmatory analysis, but we have a level of confidence that remittance patterns definitely affect economic development. And we had challenges while working on this project. We had challenges sourcing data, reliable data from various sources. That was why a lot of our data sets were sourced from World Bank. So we are advising and recommending that subsequent projects should actually source for more reliable data and try to test what we've actually found out and see if they can derive more insights for the project. Thank you.
Okay, thank you for that presentation. So we'll be calling on the first judge, and our first judge to talk on what Team Catboost has done is Mr. Wale.
Yeah, thank you. Yeah, actually like the project. I think you guys have it is a little different. Exploring the data, understanding the relationship between remittance patterns and other sort of socioeconomic indices or social development indices. I think that's really good. So yeah, this project is really good. One other thing, I think you guys can also consider is you sort of looking at especially remittances patterns for low resource economy, right? So countries that are maybe underdeveloped or developed, and sort of see what's happening. And then also, in the last few years, for example, when we've had a lot of economic crunch, what are some of the relationship, or are you guys seeing some form of outliers in your data? So those are some of the things you can look at. But yeah, this is really good. One other thing that I mean, this is probably because I am being pedantic. I think you guys need to set up your hypothesis testing very well. I know you had a bunch of hypotheses, and I'm guessing those are all null hypotheses. So I didn't really see what the methodology is. What are you sort of testing around about? And I also saw that you're accepting or rejecting the hypothesis. Actually, you cannot accept an hypothesis, a null hypothesis. You can only fail to reject it. So I think you guys, should give that testing a little bit sort of more, so make it sort of much more scientific. I think that's probably the only part that I have a little complaint about, but this is incredible. This is great. Thanks, guys. Yep.
Thank you so much.
Okay, thank you for that. Mr. Peter, you want to drop anything on the projects of Catboost team? Mr.
Hi,
Peter.
can you hear me now? Okay. Hi, everyone, and thanks for hosting the event, and apologies for joining just a bit late. I think Wale has covered all the key points, so I don't really have anything to add per se, but I'll say keep up the good work, because this is a very important area that you are covering here. So thank you.
All right, no problem. So the next team that is going to be presenting, the next presenters are Nevida and Godwin of team GCP. So we are going to invite Nevida and Godwin of team GCP to the floor. Please remember you have just 7 minutes, and immediately it's 6 minutes and 30 seconds. I will notify you. Thank you.
Hello everyone. Good afternoon to all the judges. Myself Niveda. I'm here with my teammate Godwin to present you a groundbreaking data science project that delivers into a critical global issue, household electrification. I thank every active members of this project for their contribution. The lack of access to electricity remains a daunting challenge for many communities worldwide. Although research has been conducted on household electrification challenges in sub-Saharan Africa, the variation in area to electricity within OECD countries remain unexplored. Our project aims to shed light in their issue quite literally. This project leverages data science to understand, analyze, potentially solve the problem. We perform some analysis to uncover patterns, correlations, and trends within the dataset to extract some valuable information. Our flow of process from problem statement till model deployment, our team members have contributed more. We obtained 3 different data sets, started with data cleaning. They were merged to generate electric rural rate and electric urban rate from the merged data. Thank you. Now my teammate Godwin will continue. Thank you.
Hello, good afternoon, everyone.
Yeah, this is data preparation. Data cleaning was done on all 3 data sets. We generated the urban population features, which were being used to help in the building of the model. All 3 data sets were merged, and then we generated the electric rural rate and electric urban rate from the merged data. These are some of the visualization from the data sets. It shows the way the electricity was being distributed over the years in population, in rural population and urban populations as well. Data preprocessing, data transformation. We use the QCut method to convert continuous variables to categorical variables. Data splitting. The test train method was used to separate the data set into training and testing sets. Label encoding. Label encoding was applied to categorical columns, which is the location and value, converting them into numerical representation. Handling class imbalance. We use the synthetic minority oversampling technique, smooth, to rectify our class imbalance, enhancing our model performance. Feature scaling. The standard scaler was employed to standardize numerical features, resulting in a mean of 0 and a standard deviation of 1. Model development. The baseline accuracy. The baseline accuracy, which serves as a reference point for assessing our model performance, is found to be 0.5638. Algorithm comparison. Multiple algorithms were evaluated to gauge our performance. These algorithms were cross-validated, and their accuracy metrics are being presented alongside the mean and the standard deviations value. A visualization of the accuracy result is being displayed now. This shows the cross-validation of various models and their mean and their standard deviations alongside them too. We chose the LGB model fitting, that's the light gradient boosting model, because of it was the best performing model among others, and it was fitted to the skill training data. Its performance was assessed on both training and test sets. Model evaluation. The trained LGB model accuracy was evaluated on both the training and the test data sets. The training accuracy is 1.0 and the test accuracy is 0.994, which indicates of a well-fitted model. We have our confusion metrics here. It visually presents the way our model performed across different classes. Each entry in metrics represents the count of true positive, true negative, false positive, and also false negative as well. Here we have our classification reports. Here we have our feature importance, which gives us the features in which our LGB model was built upon. Deployment. This is the process involved in creating an interactive Python script for the application, storing the code in GitHub repository, connecting it to Streamlit for deployment, also enabling users to access the application through web hosting. Here's our video of the app that was being deployed. I'm going to play it now. All right, so here it shows our introduction and problem statements, also our aims. Then went over to the visualization where we show the electricity being distributed over the years as well. Also, the prediction aspect. Yeah, it gives us where we can put in our years and the rural population. It will help to predict if it's going to be in the low, medium, or the high class. Okay, and now it shows the medium level household electricity that was being in the year 2024. This is the list of the active members. Okay. Conclusion. This study focused on using several machine learning models to forecast power pricing in the OECD nations, which aims at improving household electricity provision. Based on the gathered insights, it is acceptable to say that predicting household electrification, the LGB model, which performs better than all other machine models, was used in this experiment. This is the link to other documentation that was being used. We have the link to our research article there, Power BI, the link to our project documentation, and also our GitHub where our code is being stored. The link to data sets also used in this experiment. Thank you very much. Presented by Team GCP. Thank you.
Thank you very much for that presentation, and right on the 7 minutes mark. Okay, so Mr. Peter, please take the floor on this one.
Thank you very much. Once again, that's very good presentation. I had some questions around the data. I know you mentioned you had some challenges with gathering data. How do you think your study would have been improved if you had access to the kind of data that you specifically talked about not being able to get access to?
Hello, can you hear me?
Yes.
It wasn't us that talked about having challenges to access data, sir.
No, because you initially talked about just now your conclusion saying that inadequate data is available, or did I hear that incorrectly? You said.
Oh.
Okay. Well, if that's not the case, what I would just add to that is that do you think the outcome of your study would have changed if maybe you had more data, or do you feel that you had enough data to have come to this conclusion that you've arrived at?
Yes, because even with the data that was being presented, the lowest performing model was actually performing very well on this data set. So if we had a more accurate model, I think it will help in building, it help in our prediction as well. So yes, sir.
Okay, no problem. You also talked about the deployment part of it. So you're hosting it in GitHub and you're deploying. Can you just elaborate about that a bit, please?
The GitHub is hosting our code, and we use the Streamlit to deploy our application model.
Okay, when you say deploy, you mean you're just connecting Streamlit to the GitHub account? Okay. Thanks. That's because it's one area that I'm very interested in when it comes to like how code is managed and handled there.
Yes.
Did you have any processes that allowed you to when you're versioning your code, how did you control your code flow? Because when you say deploy, I just assume that you're deploying something from different environments, but you just connected it. So they just be very mindful when you're using the word deploy, because deploy means that you actually have a process in place that controls how you move your Python code to across the different phases of your life cycle.
Okay, so yes, I'll put that in mind, sir. Thank you very much.
No problem. Other than that, thank you for the presentation again. Electricity and electrification is very important, and I'm sure the findings of this, hopefully you can build upon this to enhance this and maybe get some more progress on highlighting some of these electrification problems in future. But other than that, thank you very much.
Thank you, sir. I don't know if Mr. Wale, do you want to say something?
I think Peter mentioned a lot of stuff already. So good job. I think the only other thing is that I would like to see like more like you guys expanding this project, which is getting more data, especially data that are sort of unstructured. So out there you can see data around satellite imagery, for example, that you can use to sort of measure electrification, right? So, trying to sort of find diverse data set, I think would greatly improve this project. But yeah, amazing job, guys.
Thank you very much, sir.
Thank you very much, sir.
So the next team to perform is Team Gitlab, and the presenters are Busayomi Thompson Ajayi and Obadoluwa Badegeshin. So you can have the floor.
Good afternoon, everyone. My name is Busayami Thompson Ajayi, and with me here is Obalolu Agbadegeshi, representing Team Gitlab. We're here to present our project titled Building a Malaria Incident Rate Predictive Model to Enhance Malaria Control Strategies. This project is an advancement of the work previously done by Team Flask. Here we see the active members of Team Gitlab. So for this presentation, we're going to be discussing the background of our work, WHO's global technical strategy for malaria has highlighted the importance of malaria surveillance as the third pillar for moving closer to its elimination. Also, many studies have been done on using machine learning techniques to improve malaria prediction, considering various influencing factors like climatic variables, population, and preventive measures. The components of the best models typically include the continuous monitoring of the population at risk, the use of retrospective data sets, and malaria metrics that can act as predictors for malaria incidence rates. Next slide, please. However, making the best model may be a challenge, as exemplified by Team Flask's work. There were some flaws, such as the exclusion of critical factors that affect malaria dynamics, data handling flaws, and lack of interpretability. So as a result, we made it our rule of thumb to efficiently handle data, incorporate population-based metrics, and implement counterfactual modeling, and improve our model performance, of course. Some of the existing solutions include the use of canal endemical and risk maps as highlighted here, and our contributed solution is highlighted too. Next slide, please. The population variable allowed us to consider population-based metrics like mortality rate, prevalence, total malaria cases, standard incidence rate, and case fatality rates, and this shaped the way our project was done. This speaks to our process flow from data collection to the model deployment. Now, for the results of our analysis, we performed temporal and spatial analysis on the population level and preventive measures level. We classified countries into 3 groups: the high, medium, and low incidence countries. We also did a regional comparison amongst the countries and observed that Nigeria had one of the highest malaria incidence rates compared to other African countries. I would note that this was done with factoring total population, which was an oversight by the previous team that worked on this. This same analysis was also done for the mortality rate, which is a product of the engineered features. For the case fatality rates, CFR, which is an indicator for disease severity and utilized for prognosis, the temporal trend reveals that the year 2010 and 2014, as shown here, had the highest CFR. We further investigated the countries that were greatly affected in these years and observed that Cameroon, Central African Republic, and Guinea were the most affected in 2010. In 2014, Cameroon was also the most affected. Next, we did the correlation analysis between CFR and preventive measures, as it can also be used to check the effectiveness of treatment. Hence, we modeled a counterfactual scenario, and these are the results. We also mapped out countries that the preventive measures were not really effective. We also see that the preventive measures such as sanitation and drinking water were more effective than measures like IPTP and ITN. Next slide, please. We also performed spatial analysis to explore the spatial distribution and clustering patterns of malaria as seen here. Next, we'll move on to the model development, which will be handled by my colleague, Obaloluwa.
For the model development, we selected 5 features, which included the engineered features, such as total malaria cases, mortality rates, malaria deaths, total population, and malaria cases reported. We standardized using the standard scalar, splitted using the ratio 80:20. We fitted and evaluated our model using RMSE and R-square scores. Cross-validation and hyperparameter tuning was also performed using the random search CV. Here is the result of the modeling, with random forest being the best performing model with 99% R-square score with RMSE of 48.37. which is higher than what was achieved by Team Flask, having 85%. We also incorporated interpretability into our model using LIME And we can see that as the population tend to increase, the model is more likely to predict a low incidence rate relative to the malaria cases reported as seen in all predicted categories, that is low, medium, and high. Here is a demo of our model in production. So this is the prediction. So in conclusion, the analysis and approaches undertaken in this study contribute to our comprehension of malaria incidence dynamics, particularly in the context of Africa. The identification of hotspot regions with constantly high mortality and incidence rates informs precision control strategies. This research guides the allocation of resources to the areas that are mostly needed. Then achieving IR2 score, the model represents a significant scientific advancement as it has reinforced the use of machine learning approach in critical areas such as healthcare. However, limitations exist, such as data quality issues and ever-changing data distribution and shift. Thank you very much.
Okay, thank you for that presentation and right on time. Mr. Wale, you 1 point on this, sir.
Yes. Yeah. Thank you for the presentation. Yeah. I really this is great. This is excellent. But I have a few questions I would like to clarify. So what? Because I still didn't get it. What exactly are you guys predicting?
We are predicting the incidence rate.
And do you have any plots that actually shows the range of the incidence rates? And how are you defining incidence rates?
Okay, we define the incidence rates by our target variable is actually the standardized incidence rate. We had to standardize our incidence rate by using the formula of number of cases reported and the total population. The total population was not part of what we had initially, so we had to source for more data sets based on that. So we use this to standardize the number of cases reported to get the standardized incidence rate.
Okay, and this is from each country?
Yes.
Country. So basically, are you saying that your data is very small? You have only 36 training examples?
Yes.
Okay. Okay. So what about so I can see that the data set shows the incidence from 2007
to 2017.
Did you aggregate it yearly, or did you even consider like the time dependence components for it?
Yes, we considered all those stuff during our analysis.
Yeah.
And I'm trying to show okay, we consider that as part of our analysis. We consider the density using the total population, and we were able to classify the incidence rates for each country according to their according to the incidence rates using high, medium, and low categories. So we use a classification approach to do all those classifications.
Okay. Yeah. So one thing that I would say is that it is very possible also that some of the features that you're using actually has like a very strong because number of fatalities, and it has a very strong correlation with the variable that you're predicting. So that's one. And the second one is, one way to improve it is to actually be much more granular than this, which is, can you actually take a country, for example, and do like a time series forecasting based on a multivariate time series forecasting based on a lot of information that actually also takes the time-dependent approach into consideration. So one of the things you can check is you want to check if, for example, malaria cases or the incident rates are higher, for example, during the raining season or during the dry season, right? So you can get more insight for that. Also, if the data is by country, I think that's fine. But if it's more granular than that, you can also look at the incident rate, according to sort of the urban areas, the rural areas, the suburban areas, and also as a function of density. So there are a lot of ways to sort of expand this work, but I think that it's really good for you to consider that time dependent approach. And actually, lastly, the reason why I said so is that there've been a lot of intervention strategies in the last 10-15 years to try to reduce the incidence rates. And so maybe it is something that you can see if there's a trend, if it's going down, and also you can also try to see if there's some sort of pattern. So yeah.
Yes, we actually considered the effect of the incidence rates in the subpopulations like the urban areas and rural areas, and we observed that there are more incidence rates in the urban areas than the rural regions. We also investigated some preventive measures that that contributed to our models, and we discovered that preventive measures relating to sanitation and drinking water are much more important than the use of ITNs, insecticide-treated nets, ITPT, and the likes. So we considered those stuff. We actually wanted to consider the climatic variables, but we couldn't get much data on that. And due to the sequential data we have, so we couldn't incorporate that into the modeling. But we're able to consider it from a population perspective and some malaria metrics.
Okay, thank you.
Thank you, sir.
Yeah. Okay, thank you. Mr. Peter, anything to add on that, sir?
Nothing major, just I would like to ask if you can just show the data entry part of your demo again, please.
Okay, sir.
So I think it was about halfway. You can just jump to about halfway there where,
okay.
Yes, yeah. Okay. Yeah, you can pause there. Sorry.
Okay, sir.
So my question is more along the data entry. I know it's a demo, but just to clarify, I know you had just above the 500 here. You had number of malaria cases.
Yes, sir.
So if you just go back just a bit so that we can see before you scrolled up. I think it was just a few seconds on this. Yes. Just a few more. The point I was just trying to make is I would want to understand what the difference is between the total number of reported malaria cases and the malaria cases in this demo.
Okay, you mean the total number of malaria cases? And
yes, which you have as
reported...
1,000 there, and then you have malaria cases there as
okay. Okay, the reported malaria cases are the number of malaria cases reported, like newly reported malaria cases. So that's actually one of the numerators for the incidence rate. But the total malaria cases covers the total malaria cases recorded that have been recorded in the country in the time past.
Okay, so it's not clear from this because you just have what is the reported malaria cases here, and then you have malaria cases as a different number. So for me, it just did not add up what was going on here. But I think you've explained just a bit. It's still not clear, but just something to be mindful in future. I know it was a recorded demo, but it's worth just, talking about this just a bit here, because this doesn't really, make any sense, unfortunately, to me. The second feedback I had, I think Wale talked about a bit, is just, this is an ongoing thing and it's fast changing. So the data is very likely going to be changing over time. So if you've collected data over a given period, I think it's safe to assume that the data, you cannot treat the data from, over the last 10 years as they all have the same, they all have been, you cannot extract the same kind of parameters or variables from all, over the last 10 years. The expectation is that because it's changing, if you segment the data into given time frames, you might be able to extract more data, more meaningful variables from your data because of the way the data has been changing. Unless you have certainty that the data has been, immune to all these other factors that have been going on in the advancement of malaria, malaria reporting rate. So just be mindful that this is a potentially almost like a time series data. I think someone else have mentioned that, and the variables would have been impacted at different points by different things.
Yes, we actually considered that it was part of our limitations when we said we have limitations based on the ever-changing data distribution and shift. So we consider that's why doing the analysis and modeling.
Okay, that's very good. But once again, well done. I think it's
thank you.
Very good.
Thank you very much. Yeah.
Okay, thank you for that. The next group presenting is the Kubeflow group, and the presenters are Cynthia Njao and Odufuwa Clinton Ajibola. So as usual, you guys have 7 minutes. You can start now.
Okay, thank you. Hello everyone. I hope you can hear me. This is Team Kubeflow, and our topic was on predicting school completion rates in developing countries. I'm Cynthia Njao, and my fellow presenter is Clinton Ajibola. These are our active team members. Education is the most powerful weapon which you can use to change the world. In diverse situations, a low rate of school completion can be attributed to a number of issues. Poor education can result from a lack of resources and facilities, which can make students distracted and less inclined. Also, inadequate support mechanisms for pupils with special needs or learning difficulties can also result to low school completion rates. Our aims and objectives were to analyze educational and socioeconomic factors that contribute to school dropout rates in developing countries, developing predictive models that are capable of accurately predicting school completion rates among students in targeted regions, and also model evaluation and implementation. For our methodology, we followed this procedure: data sourcing, data preparation, EDA, feature engineering, model building, model deployment, and then we lastly did our documentation. Data sourcing, we collected and sourced our data from UNESCO Institute for Statistics. Our data set contained 1,600 rows and 11 columns. It had features like region, country, year, school completion rate, gross intake ratio, among others. For data preprocessing, our data set was divided into 3 specific categories. That was primary education, lower secondary education, and upper secondary education. Our data set had missing values, and we handled them by filling them with the mean of the respective columns. For the duplicated values, we dealt with them by dropping them from the data set. For the EDA, we looked at various features like comparison of completion rates across the data sets. That was primary, lower, and upper. There we saw the primary had the highest completion rate, while the upper secondary had the lowest. We also looked at the literacy of people aged 25 to 64, and we saw that the men had a higher literacy rate than the women. We also looked at the completion rate per year, completion rate per region for the primary, upper, and lower secondary. I invite my fellow presenter, Clinton.
Okay, so good day, everyone. My name is Odufuwa Clinton, and I am the second representative of the Kubeflow team. I'll be dwelling on the model building phase. So in the model building phase, the following operations were being performed. The first, which is the data normalization. This was done using the min-max scalar module in the Scikit library, which was used to scale the values of the dataset between the ranges of 0 to 1. This was done to reduce data redundancy, that is data repetition, and also to increase the workflow of the model building. The next operation after that, still on the model building slide, the next operation after that we carried out was the train test split, splitting the data into the training set and the division set, giving allocating 80% of the volume of the data set to the training set and 20% to the testing set. After that, we went on to the model building, and after, based on due considerations, we were able to go with the regression technique since the target variable y was having a continuous variable. We went on with the model building, and the model which we used during the model building were the linear regression, the lasso regression, the ridge regression, and the gradient boosting regression. Over to the next slide, please. Then after the model building, we went on with the parameters hypertuning. This parameters hypertuning was done to get the best parameters of the model for optimal performance. After the parameters hypertuning, we went on to the evaluation of the model using the various evaluation metrics in regression technique, such as the MEE, the MSC, the MEE in short for mean absolute error, the MSC in short for mean squared error, RMSC root mean squared error, the residual sum of squares, and the auto score. And judging from the evaluation score based on the primary sub-level education, the best performing model was the ridge regression, having a score of 0.1173 in the primary. And over to next slide, please. And also for the lower secondary school sub-level education, the best performing model was the ridge regression, having a value of 0.1263 in the mean absolute error. Over to the next slide. For the upper secondary, the best performing model was also the ridge regression, having a score of 0.15326. This was judged based on the value. The HEMI, the mean absolute error, is being judged based on the best performing model is always having the lesser value, that is the value tending towards 0. And the one with the best accuracy score is being judged based on the value tending towards 1. And the one with the best accuracy score is being judged based on the value tending towards 0. And the one with the best accuracy score is being judged based on the value tending towards 1. Over to the next slide, please.
Sorry, I think his connection is bad. Maybe I can
Sorry
take
about
it.
the network issues. Please, over to the next slide, the deployment state. The deployment phase. During the deployment phase, we deployed the model using the Streamlit app, and we deployed the best performing model, which was the ridge regression, to the lower secondary school sub-level education. And we went on with the deployment phase.
So you guys have 30 seconds more.
I'm so sorry, I'm having network issues at the moment. So I was talking about the model deployment phase, which was done using the Streamlit app, where the best performing model was being deployed and used in performing prediction on the completion rates of different sub-educational levels based on the X features respectively. Looking at the features on the slide, we worked on the primary education prediction rate, and we imputed some X features. Then we got a prediction score of 0.72, which is equivalent to the 72% of the completion rate in the educational system. Next slide, please. Then, in conclusion, the primary objective of this study was to identify and forecast key factors influencing school completion and also developing optimal models to help predict school completion rates in developing countries. Then the recommendation slide. The recommendation during the exploratory data analysis phase, we discovered that the percentage of government expenditure of education had a significant impact on school completion rates. Thereby, to fix this, there should be an increase in government funding allocated to education expenditure. Furthermore, special incentives should be provided to children at various educational sub-levels in order to motivate and support them in completing their education. Thank you.
Okay, thank you for that. Um, so Mr. Peter,
Thank you very much. Once again, I want to say thank you for working on this very important topic, because education is, especially in developing countries, we all know needs really, it needs to be looked into. And there's, as you mentioned, I think there's some government investment opportunities, although one can argue maybe there needs to be some options for private sectors there to maybe step into it, but that's for another day. You talked about the different models that you use there, your approach is there for. Can you explain why you settled on linear regression approach? Why you didn't try to use any other? Why specifically regression?
I used the regression techniques based on the values of the target values. The target value were having continuous values in the sense that they were having values having infinite values in example 0 points and upwards. So we use regression techniques when the target values are having value, the target variable is having values of continuous values.
Okay, that's fine. And regarding so how did you, because your outcome, because you said, and correct me if I'm wrong here, what your outcome was to, actually, can you just remind us what your outcome was again for the regression?
The outcome was based on the mean absolute error in terms of the evaluation. We used the mean absolute error to judge for the best performing model, which was the ridge regression in the 3 sub-levels of education.
Okay, so it's about predicting completion rates in the trees. Okay, awesome. And
yes,
okay, that's fine. I mean, you can see clearly that even though just going by the R square, value here, although, and it could be maybe the data was not accurate or not, but 72, I think, was what you showed earlier for the best performing model, 72%. Do you think there's anything that you could have done to improve this? Maybe was it the data, or what do you think will get this to increase the the model's ability to predict these outcomes that you put here? Or was it the right model?
sorry, the model's performance was not based on this model deployment. Is just merely predicting. We gave it some input values based on the X features. We gave it different feed columns where we supply the values based on the X, based on the independent variables used for the prediction. Then it's mainly just predicting the value for that year, the completion rate value for that year. The performance of the model was judged based on the mean absolute error, which was 0.1263 for the primary level and 0. Which was 0.1173 for the primary level, 0.1263 for the lower, and 0.1532 for the upper, which signifies optimal performance in the model.
Okay, so you use the MAE here instead of the R square score. I was
Yes, I
referring to the
used
R
the
square
MAE.
score. Okay, that's fine. I guess if I'm going by the R square score, And I know maybe one might have a different view here, but maybe you can just explain why you used the MAE as opposed to the R-squared score.
I used the mean absolute error because based on my knowledge of the mean absolute error, the mean absolute error judges the performance of the model based on the value which tends towards zero. If the mean absolute error was to have a value of zero on the dot, and that increase our best performing model, which is almost impossible because there can be series of overfitting, which causes a model to be 100%.
Okay. And my last just maybe sort of feedback is in terms of bias. Yeah, like how do you think you've handled bias of the data here? Because linear regression is the pattern that is very prone to bias when it comes to data like this. Like, is there anything that you could have done to maybe identify the level of bias in your data, or do you think there was any bias in the way your model was predicting or handling these errors?
Based on the four models, the ridge regression and the lasso regression was there to help correct the bias that could have occurred in the model, because the ridge and the lasso is known as the L1 and L2 regularization, which helps to prevent overfitting in the model and helps to shrink the coefficients of the features towards zero, thereby selecting the the features having the most impact towards the prediction of the model.
Okay, that's fine. Well, once again, thank you so much. Again, presentation was very good. Cheers.
Yes, thank you very much.
All right, thank you. Mr. Wale.
Yeah, thank you for this presentation. One thing I probably just wanted to mention is you typically use the mean absolute error because of outliers, right? So if you have a lot of outliers in your data, that's probably when you want to use it. Another metric that you can use is the MAPE, so which is the mean absolute percent error. And what that does is that it actually normalizes your result to be sort of between 0 and 100. Our 0
Okay.
terms of ratio. And so when you know that when you get closer to 0, your model is good. But a lot of them they have their pros and cons. R squared sometimes is not robust to, like, if you have additional data, it could be problematic. So that's one thing I would say. The other thing that I mean, this is nice presentation. Education is important, but one thing I didn't really see is I would have expected more insights than analysis for this project, right? So I would have one of the things I would have done is try to find some of the coefficients contributing to model performance, try to do some form of model interpretability to understand what are the main reasons that completion rates, for example, are high or low, right? And so I think that having a sort of much more insights driven analysis would have definitely helped it better than a lot of the models that we have. So that's my recommendation.
Okay.
All right, thank you, sir. So, Mr. Charles, don't know if you want to drop in anything on that.
Yeah, sorry guys, I came in a little bit late. So my question is like, what did you consider for your model selection process?
Um, do you mean before selecting the model for the model building?
Yeah, exactly.
Yes, I considered overfitting in the model.
Just the overfitting. What process did you? I mean, as a team, I just want to know how you guys went through this collaboratively.
Sorry, I didn't get you.
I said, as a team, how did you guys approach this? Like, when you wanted to start this whole process, was there any diverse opinion in terms of how you went about the selection and the process and the procedure?
When selecting the independent variable, we basically use most of the variables in the data sets minus the response variable, which is the y variable. That was some of the things we did during the prediction of the model.
Okay.
Okay. Is that all, Mr. Charles?
Yeah, that's it for me for now.
All right. Thank you, Team Kubeflow. So the next team to present is Opencv, and the presenters from Opencv are AK Monk, AK, and Subi Jane. So you guys have the floor, and you have 7 minutes for your presentation.
Good afternoon, everyone. Hear me?
Yes, we can hear you. Continue.
My name is AK from the Opencv. I'm presenting with Sobi Jen, animal species detection using detection has become a task in the field of computer vision applications ranging to ecology research. Now, the effective computer vision that can be deployed as part of a system to detect wild environments on highways. It has potentials for various design and inclusive deep learning approach for animals that suit various contexts, intends to enhance road safety by detecting animals and also boost wildlife, refine animal population, and to low V8 model dictation for animal detection and classification, data pipeline. This next slide. We had a data set on this. We also were all of them were from Kaggle. First, the data set was classes. The second data, none of them was annotated, and we had images that were so of low resolution. To look for additional data set, we combined both the took out the one and the one that had high resolution. Processing, of course, we removed the data set that the image resolution said, then the images that had the high resolution. We worked on it when we data and observed that we had about 3,600 image files. Here we can see the zebra and rhino count with having the lowest. And of course, our aim was to check the number of objects in each image file, and observe that there were variations to 25. Some had 2, and the rest aspect ratio. Because the resolution of this image file will affect the. You had to check on that too, and varies from 0.5634, which was. Now the next, the table we're seeing, model summary, shows the model summary, had the evaluation metrics, and then mean average percentage. And it showed an overall performance 95%, but the highest of it was 0.5% and 0. And for cheetah, we had 79. All was 0.5 mean MAP average precision threshold. Then the F1 config, we had overall performance 3% at 0.5. Slide, please. Okay, the metrics, and here what we have, it shows the performance, the training. So sorry, of object where the model accurately identify different animal species. Now each what the column correct. Now if there's any number, it shows that there was items that were misclassified. Slide. Okay, this the metrics, the test set was deployed using Streamlit on Hugging Face. It has the capacity to identify objects. Please. Now, there is need for scientists or researchers that into the evolution of this model to note that the primary of focus will be to extend the model to adapt to new
just
and previous.
30 seconds more. And please, can you work on your audio? I think it's breaking a bit on our end.
Okay. Previously unencountered animal species. And lastly, involves expand data sets to encompass a range of species. Models accurately dictate various animals because our data sets have 10 classes. So futures to expanding the data set. Thank you very much.
Okay, thank you for that presentation. I think there was an issue. So, Mr. Charles, would you want to take this, sir?
Absolutely. This is a very good presentation. So I have a few questions, so we can just go through it real quick, one after the other. So my first question is like, I know you're doing instance segmentation. What will be advantage of doing instance segmentation over semantic segmentation and identifying all the animals that you're saying? Did you consider using semantic segmentation over instance that you have right now? If anyone on the team can answer that.
what we basically did was, I know that there's an image segmentation.
Mm-hmm.
We didn't consider that because in our set has bounding, so which in the dictation of the images. So we didn't do in image segmentation.
Oh, okay. The other question I have is around, like, you have different classes of animals that you've pre-labeled, and the assumption is like you're looking for this animal type. What happens if you see an instance of animal type that is not labeled? How do you handle that? Do you have another class or an exception class where you drop all those type of animals? Or you're just looking for the specific animal types that you have?
Okay, because of the data set, they were already classified.
They're already pre-classified. Okay. Okay.
Yes.
Cool. So I know you did the analysis. Did you consider using framework like YOLO V8 for identifying and tracking all these objects? So one of the things I'm really interested in is how this would perform if I have a real-time video that I put in all this Safari, and I'm trying to track all these animals in real time to see the population, to measure things like population density, how many animals go through a particular area at a certain time of the year. YOLO V8 does a great job at that. Did you guys at any point in time work with that, or you just did all this exploratory analysis? And
no, we did. After testing the model, we also knew that some animals, which one of them was in the slide. We tested it and it worked.
Okay. Yeah. I'll take this offline and try to find out more with you guys. What you did. Cool. Great presentation.
Thank you, sir.
All right, thank you, sir. So, Mr. Wale, to drop in on this.
Yeah, I don't have much to add. I think Charles asked a lot of the questions. Yeah, and I think for me, this is mostly, I think you guys are doing an object detection and you have ready-made data set. And I think at some point you're using YOLO V8. So, I mean, it looks kind of straightforward. One of the things that I am, I'll be interested in are some of the questions that Charles asked that, what about if you want to count the population, for example? What is the latency, for example, if you have videos and you're tracking these videos real time? How is it going to work? What if you have an animal that is not even in your data set or your examples that you train on? What are you going to handle such unlabeled data set? So there are a lot of questions, a lot of ways to expand it. And your evaluation data set also looks really nice, pictures of single animals. What do you do, for example, if you have different sets of animals moving together? How does it identify multiple objects in a certain frame, or multiple frames in an image, for example? So those are some of the things I would say to sort of consider, environments that are constrained, for example. So, but overall, good job. Thanks.
All right, thank you, sir. So, Mr. Peter.
Nothing to add, to be honest, other than yeah, this is it's been a very good presentation. Keep up the good work. Thanks.
Okay, so the next group to be presenting is Team PySpark, and the presenters are Ajarat Adamu, Jimo Said, and Nikita Ramachadran. So you guys have the floor and you have 7 minutes for your presentation.
Okay, hello, can you hear me?
Yes, we can hear you. Go on.
Yes. Okay, Good morning, everyone. I'm here to represent the team PySpark and present the work that we have done during our project using diet analysis to predict and prevent child malnutrition. So this is our team, and let's move forward. So the problem statement. So this project aims to leverage machine learning, data science, and also data analysis to analyze diet pattern in child under 5 years old globally with the view of predicting and preventing malnutrition. So our work was based on the team Seaborn, who worked on the winter cohort on 2023. They worked specifically on overweight and underweight. It's good to understand that we have 4 types of child malnutrition, which are overweight, underweight, macronutrient deficiencies, and also undernutrition. So on our project, we included the macronutrient deficiencies and also the undernutrition variable to make the project more global and to have more efficient insight and models. So the methodology. Our approach to tackling the problem and the preferring solution is as follows. So data sourcing, data cleaning, EDA, time series prediction, we did feature selection and also engineering, and the modeling and the evaluation. So for the data description, we went on the United Nations International Children Emergency Fund and we have a data from 346 geographic regions and the nutritional report from 1970 to 2022. So upon cleaning, dropping columns, and so on, we have sourced such important columns which are stunting, severe stunting, wasting, severe wasting, underweight, severe underweight, overweight, and obese. So we went on the EDA. So the EDA, it was just for us to see how our variable interact, like to see how the variable are more distributed by country and so on. So for example, you can see that we did the rate of the burden of malnutrition by each country, the breastfeeding pattern of mother in each country. And for the time series prediction, we use the Facebook Prophet to do the time series forecasting on year-wise average data frame, because when we work on our data frame, we had 2 data frame, which are years-wise average data frame and also country-wise average data frame. So for the forecasting, you can see, for example, for underweight globally, we shall be expecting a massive drop in underweight cases starting from 2022. Although it tried to raise its ugly head in 2025, but it was defeated and it's continued its downward trend. So for the model, it's good to understand that we have many columns, such as we have 98 columns. So it was good to have important feature, and to have them, we use the feature selection engineering, such as lasso, ridge, and random forest regression. After we had our important feature, it was good for us to see if they have collinearity. So we went and we have our correlated features. So, and after we did the variance inflation factors, and we saw that our correlated features are highly correlated because they have a variance inflation factor higher than 10. So we performed the principal component analysis on them. And after we merged this data frame of the principal component analysis with the uncorrelated features. So these give us good predictors for our models. And after we did the machine learning and deep learning model, for the machine learning, we did ElasticNet, XGBoost, linear regression, and also gradient boost. And for the deep learning, CNN and RNN. And we found that ElasticNet and ElasticNet, CNA, and the gradient boost in this order perform well based on the MSE, mean squared error. So, and also we did a dashboard for our forecasting, time series forecasting, as you can see a little bit about how we did the dashboard to see the trending of each specific column, such as stunting, severe stunting, underweight, and so on. So To summary, to combat malnutrition, we can do the following to achieve this goal, such as intervention should be focused not only on increasing access to nutritious food, but also on educating the individual about the importance of a balanced diet and healthy lifestyle. Also the government, healthcare professional, and also communities can use the dashboard to better understand the situation and educate people. And also the prediction should be carefully studied and used as a guide in developing frameworks needed to fight this burden of malnutrition. So thank you for the attention.
Okay, thank you for that presentation on right on time also. Going with Mr. Charles once more.
You can mute it, my brother. I think there's an echo back fit. All right, cool. So this is a very great presentation, right on the point, and succinctly presented. Thank you so much to this team.
Thank you.
My quick question would be like, you have all these variables, but you don't really know what matter. I mean, which one adds more weight or things like that. Did you do principal component analysis, PCA, on your time series observations before you proceeded? How do you know which one influences?
For the time,
yeah.
Okay, for the time series, we have a specific data we use for the time series forecasting, and a specific data we use also for the models and the machine learning and deep learning. So that's how we did.
So I didn't get that. So did you do any PCA, or you just went and picked up
on time series? No, we didn't do any PCA. We did PCA on the machine learning and deep learning models.
Okay.
Yes.
All right. Then you say you use Prophet. Why did you consider Prophet over any of the other time series models out there? Is there any reason?
Because to be honest, it's Prophet that I learned during my internship. So I saw that it performed very well. That's why we use.
Yeah, I mean, I know that about that.
I'm Nikita and I'm a team member. So one more reason was that it was robust to outliers in the data. So that was one more reason why we considered Facebook Prophet.
Yeah, which is a very valid point. But one of the things you might want to do next time is to basically run your data set against multiple instances of all these models and frameworks out there. And you can do model selection because you never know. Because you make a lot of assumptions naively.
Sir, actually, I had tried ARIMA model, but our data set was not becoming like the time series was not becoming stationary, and we required it to be stationary to perform ARIMA. So we dropped that idea of doing.
So one thing you want to do next time, your presentations are great, but you want to highlight all these points before you arrive at what you used.
Okay.
Because it's going to be helpful for anyone taking over this project at some point in future to build on it, to know all those things so that they can have that prior knowledge in terms of extending your work and things like that. So, well, other than that, I will yield for Wale and Peter. Yeah, great presentation, guys.
Yeah, thank you.
Okay, thank you, sir. Mr. Peter, anything to add?
I just want to also congratulate you on this presentation. Again, I like the fact that, you know, you've built on the work that your previous predecessors have done. You know, it's nice to see that lineage and to see actually there's some progress. You know, you've made, Charles said it all already, but I just had one question to ask about the size. How do you handle the size of the data? You know, you said the data set looks like it was a lot.
Yes.
But maybe you can just shed some light on how you handle the data and maybe any tips you can also leave down for your colleague, whoever picked this up regarding just this data handling.
Okay. The first thing we did was about to select the targeted variables. because since we know which columns the previous team used to do the prediction. So we use the column and we add the micronutrient deficiencies and also undernutrition variables. We went on the United Nations website to see clearly column by column, even if you have a 98 column, we see how they impact and how they are specific on if they are very impacting on overweight, underweight, and micronutrient, and also undernutrition. So we selected a targeted variable, and for the orders, for the predictors, we went through the feature selection. First, we have our feature. We set a threshold of 0.001 to select the important feature. After that, we went to look at the correlation between the features. We have our correlated features, and after we did the variance inflation factor, we found that they are highly correlated, which are some are more than 100, and so it was it wasn't gonna give us a good prediction. So we performed PCA on them. Other side, we have uncorrelated features, predictors. So we merge them together to have good predictors, and that's how we build our model.
Thank you very much.
Yeah, thank you.
Okay, thank you, sir. So, Mr. Wale.
Yeah, thank you guys. I think this is good. Really nice presentation. I think my only question is, if you guys look at underweight, this deck that you're showing in 2023, there's this huge drop that we can see. Do you guys know what can be the reason for that? And I know that's the forecast regime, right? Okay, yes. So you for that. Okay, it's the behavior of the model then. Okay, I think that answers the question already. Thanks again.
Thank you.
Yeah, bye.
Okay.
Okay, thank you for that. So the last team to be presenting for today is team Scikit-learn, and their presenters are Emmanuel Boniface and Ibe Chidera. So you guys have 7 minutes for your presentation, and you can start now. Team Scikit-learn.
Okay, yeah, we are here. Just
I think you're muted, you know.
Team Scikit-learn.
Sorry, I'm harding.
Yeah. All right.
Sorry, guys, I'm having a hard time finding the presentation slide. Yeah. I think it's visible now.
Yeah. Hello. Forecasting the probability of conflict arising in an African nation. My name is Boniface Emmanuel Chosen, team lead for team Scikit-learn. Next slide. Meet our team. This is an overview of our team members. Next slide. So our presentation is going to be running from the introduction to the summary of our solution. Next slide. Yeah, conflict in African societies arises from clashing interests, values, and needs. Now the debate is between greed versus grievance. the impact of uncontrolled conflict ranges from violence to economic setback, loss of life, and infrastructural damage, among others. Next slide. Our solution aims to improve upon the previous study focus, closing the data gap in the previous study and expanding the limited model evaluation or assessment. Next slide.
So thank you, Emmanuel. I'm going to be taking it up from here. So when we approach our project, we first selected the right data sets. We surfed across the internet and find the right data sets, and we performed data analysis, which include initial data statistical analysis and creating visualizations of the data. And we selected the most important features to use in our predictive model. And we also trained and optimized our model using different algorithms and parameter tuning. So finally, we deployed using Streamlit and interacted with our model. So when coming up across our data, we first understood the data. So we had many data sets, including the previous one and the one provided by Hamoye on this project platform, and also the new data set we found on the socioeconomic database of African Development Bank. So after analyzing the data, we found out that the common type of conflict, which the common type of conflict were, and the duration of conflicts, and the correlation between fatalities and conflicts. So when we see the common types of conflict in Africa, the most common type is battle, and which is followed by violence against civilians and protests. So this suggests that conflict in Africa often involved armed actors, which means there is a high casualties within those conflicts. So as mentioned, there is a positive correlation between fatalities and conflicts. So conflicts in Africa are often highly violent, and they result in significant number of casualties. So we were able to learn this from our dataset early stage on. So the other thing we understood was the duration of conflict. So the average conflict duration was more than 100 days within Africa. So there was a difficulty in identifying whether a conflict has ended or not, because those conflicts often happen frequently, and there is difficulty in identifying whether the conflict has ended or it is in a surge or a slowdown of the conflict happening, you know. So how was the data pre-processed for the conflict prediction? So the first thing we did with the data cleaning and pre-processing was removing rows with missing values. So we handle outliers and ensure our data quality by standardizing and scaling our numerical values. So the other thing we did was data sampling, because we had about 300,005 data. We used random sampling techniques and also maintain representativeness to enable faster computations without sacrificing accuracy. So the other thing we did was to enable our fast model, we use one-hot encoding, which means we transformed into binary vectors a specific type of events and attributes, so that we can have a faster and accurate model. So how did we train our model? So the first thing we did was creating a training, validation, and testing datasets. After that, we selected the features which are important to key factors guiding the model's decision. So the other thing we did was trained using hyperparameters to make the model uniform and more consistent. So we saved those hyperparameters using joblib to implement it on future models. And we also implemented like performance metrics like accuracy score, classification reports, and everything. After that, we selected the best models accuracy using a unseen dataset, which was a dedicated test dataset for our model. So the selected model was random forest classifier with a 94.81% accuracy. So our deployed model, there was a, yeah. So we try to predict whether the conflict will rise in that nation or not. So our deployed model will take as an input as the type of conflict, the country, and the specific location of within that country, using latitude and longitude, also the name of that specific location we want to predict with. And after that, we click the predict model, and we understand how we will see how likely will there be a conflict within that location. So the matrix lasts from 1 up to 10, which illustrates how likely a conflict is going to occur within that location or not. So the research findings, the key findings is the random forest and decision tree methods achieved higher accuracy, which is a 89% and 94% accuracy, and also socioeconomic indicators significantly predict conflict occurrence in African nations. And the other thing we understand was socioeconomic, political, and academic indicators outperform other models which rely solely on conflict event based predictors. And the other thing the challenge we faced was our model had a hard time predicting events with rare conflicts, which means because of the unavailability of data, it have a hard time predicting those type of events. And the future research we recommend is explore data implementation. All right. So investigate, and I think we have finished the presentation. Thank you very much.
Okay, thank you for that presentation. So, Mr. Wale, want to drop anything?
Yes. Thanks for the presentation. I wasn't sure if I missed that. Can you go to the deck where you have your results? So you don't have your model results?
Oh, yeah. The notebook?
No. So you developed the model, right? And then, okay,
yeah.
I didn't see that in your deck. That was the, that's a confusion. Okay. And so you have your accuracy score to be 71%. Is that the best model results that you have?
So the best model result is the 94.81%, which is around the forest classifier. We tried different models, to name a few. We tried logistic regression, the extra tree classifier, the bugging classifier, and all them. And they have a varying accuracy, but the highest accuracy was with random forest classifier.
Okay, and did you do maybe feature importance score, or maybe some sort of interpretability techniques to know what are the features that are sort of exactly contributing to your model?
So we tried to analyze the correlation factors within each data, within each features or attributes within our data. So there was about 34 type of attributes within our data sets. So we selected the most positive correlated values so that we can have a better predictive model. And as mentioned, it was a large data set with about 300,000 data or rows. So we use the positive correlation method there.
Okay. All right. Thank you.
Okay. Thank you. Mr. Peter want to drop anything?
Hi, once again. Yes, thank you so much for the presentation. I think it goes without saying, you know, conflict. Yeah, something I was just reading an article just now of, you know, that's what the potential outlook for conflict in Africa would be with all the coups and everything going on. So it's a very important presentation. I don't have anything technical to add other than to what has been said already. So I'll just rest it and just say congratulations on concluding. Thank you.
Thank you.
Okay, Mr. Charles.
Yeah, I mean, I think this is a great presentation. I think Wally and Peter nailed it. You guys it seems great. But one thing I wanted to add to this is I just want to ask the questions around the adaptability of the model, because all these things are event driven. Like if a conflict is going to happen, there's a bunch of indicators in event, which you guys are capturing very well right now. But there's a variability in this event, and people adapt to these things. Like you see what's happening in Rwanda, where they're doing some stuff to mitigate something happening and stuff like that. So my question for you will be, is this model going to capture all these new inputs that basically affects the eventual outcome over time?
Okay, so as we try to mention, there are different type of conflicts within Africa. So, for example, if we take protests, there is a peaceful protests and there is a violent protest or demonstration. So those type of conflicts come at a mildly fatal or mildly destructive conflicts and a very highly casualty conflicts. So basically, we try to analyze those type of conflicts in relation with political, socioeconomic, and other factors. So, for example, if a certain type of conflict is frequently happening within a period of time for a country, and if that country is showing a economic decrease or a socioeconomic impact is negative, we'll assume that there is a relation between that conflict and the socioeconomic impact. So having that said, we, as mentioned, created a matrix system. So basically, if there is a protest and if there is a decline in socioeconomic aspect of that country, and if our model sees that type of relation, it will give it a highly conflict, which means a highly impact conflict. And if there is a conflict, but the socioeconomic impacts and everything is kind of stable or better, we will assume that conflict is not highly affecting that country within that specific time period. So the relationship is kind of intertwined within these aspects.
Okay. Cool. Great job. Thanks a lot.
Thank you.
Okay. And with that, we have come to the end of our presentation. So any final words for our interns regarding their performance so far, Mr. Wale?
Yeah, I think the quality of the solution, the quality of presentation, of the modeling, I think they've been really, really, really good. So good job, guys, everyone. I also saw that in some slide deck, some team had links to like a research paper that they've written. And I think that's a really good one. And so at some point I'll probably be contacting some groups to sort of know more about the research paper and see maybe how we can get that published. So, but yeah, amazing job, everyone. Thank you.
Okay, Mr. Charles, anything?
Yeah, great presentation. I'm sorry I couldn't catch it all from the beginning, but with what I saw, the quality of work, it looks great. I know you guys have put in a lot of effort into this, and the more you work together collaboratively as a team, the better you become. So what part of this training and what you guys have learned is to work together in a team and be able to like synergize with everyone. Everybody's mad, but when you come together as a team, you do great things. So and always even though you've done this, don't rest on your laurels. Don't call this the end. You gotta keep doing stuff, because the more you know, the more you discover you don't know. The more you read about all these things, the more you find out new things. I'm learning new things from you guys as you're doing this. We're all learning from each other. So one thing I want to encourage everyone is just to keep doing it. There's no end to this. It's all interesting. There's a lot of new things that are going to happen in the next few months that you're going to key into. So overall, great presentation. I just want you guys to stay hungry and keep going for more. But this is a good beginning for everyone. Thanks a lot.
Mr. Peter.
Thank you. I also want to thank you all for the great presentation and everyone who attended, because, we're all here with the aim of, trying to, as already said, to learn and to encourage you guys to keep pushing harder. Just think about what happens next is what I would say. Don't let the research and the inquisitiveness stop here. Just think about what you can do next, where you can take all the learning you've learned and what else you have. So tons of open questions and feedback you guys got. Don't just, brush it off as the presentation is over. Try and go back and see how you can use all the, feedback you've got from this. And that's it for me. Thank you.
At this point, I'd like to say a big thank you to all our presenters, the team, our judges, Mr. Wale, Mr. Peter, and Mr. Charles, for a successful session. Myself and the rest of the Amoye team are honored to have hosted you on what is the climax of a rather intense 4-month journey in the field of data science and its related field. We can't wait to see you all soar high in your chosen fields. Please take note of the following. The result of the grand finale presentation will be computed and be published on Slack next week. The internship officially comes to its end on Tuesday, the 5th of September 2023. Congratulations to all that have passed this. Your certificates will be ready by next week, and you will receive yours by email if you qualify for your certificates. More announcements will be made on Slack. On that note, it's a goodbye from me. Do enjoy the rest of your weekend. Thank you.